Welcome everyone. My name is Jakub Krukar. I'm a PhD student at the Plenary University, and I'm going to tell you about a study that we've conducted with Ruth Conroy Dalton, which forms a part of my PhD. And the study is about art galleries. Art galleries are very interesting spaces, even if you're not really crazy about arts, and this is because modern art galleries, especially, are usually very simple spaces, which only have white walls, white ceilings, and art objects located in them. And if you really think about it from the architectural point of view, the relations between these objects and the layout of the space is the probably most powerful curatorial tool available that can guide or steer visitors' experience. And being at the Space Syntax Symposium, I don't really have to tell you how many papers have been published on this in this community, including the probably most recent edition by Pepones and Lu on co-visibility of pictures. But we wanted to perhaps approach it from a slightly different angle. Coming from the building usability, we thought, what can make a gallery usable, if we can even call it like that? And if you read some literature in curatorship, in the field of curatorship, I think is the word, it's very difficult to find any specifics because people have very different approaches to what constitutes a good art gallery or a good art exhibition, and this is fine. This is why we enjoy these galleries so much. But I found a few quotes which seem to be consistent across the literature, and people seem to agree that museums exist in order to acquire, safeguard, conserve, and display objects, and that the user must be able to get something out of it in the end. So these are very general statements, but it's fine. Although I'm an experimental psychologist and I don't like this imprecise wording, so to me, the one on the top is definitely about visual attention, and the one on the bottom is about spontaneous memory. This is the word this is the words I would use, and the best thing about it is that I'm quite lucky to do this research in the times when we actually have methods and technology to measure that. So mobile eye tracking can be used to measure visual attention nowadays very well, and for spontaneous memory we have a whole set of methods which have been developed for the last 150 years. This gentleman is German experimental psychologist from the 19th century, Hermann Ebbinghaus. And ever since we had many different methods developed that we can use to measure memory for pictures in an art gallery, for example. So if you want to do a study in an art gallery, you should get some art first. So I went around and I got some art. This is a set of artworks prepared by Susie Bellamy, who's an MA student in Fine Arts at Northumbria University. And you also need some space. So I found a little art gallery, which students at our university usually use for their shows, and I ended up with something like this. And I prepared this gallery in two different versions. It's the same structure of walls, but I changed the relations between the pictures. So you can see two different conditions, and I had half of my participants going into the first one and half of them exploring the second one. I will talk more about the differences between these conditions later, but you can already notice that in condition number one, pictures are located more centrally and individually, whereas in condition two, they are clustered together. And then I had my participants walking around this space with an eye tracker on, but I'm not going to focus on eye tracker today. This is published in a separate paper if you are interested. I'm going to focus on memory tests, and we had two memory tests that we have conducted. The one on the right is a standard computer recognition task. The way it works is that you have pictures appearing on the screen. Half of the pictures which you see are the pictures which were really in the art gallery which you have visited, and the other half is either completely new or modified versions of the old pictures. And your task is to recognize by pressing a button whether you've seen it in the gallery or not. What we measure is only the correct responses, and we take the reaction time of these responses. So the idea is the faster you reacted to a picture which you remember seeing inside, the more certain you are about seeing it there. So the memory trace of this object is stronger, you could say. And the task on the left, we call it a miniature task. Participants had miniatures of the pictures and the printed version of the layout of the gallery which they have visited, and they were asked to place the miniatures on the layout where they think they saw it. So here no distractors were provided, this is just the pictures which were already inside. So of course they conducted the computer task first. This is an example result of the miniature task. What we measured was whether the picture was placed back on the correct wall. So we also call it back to the wall measure, because I couldn't find a different name. But now, even looking at this, you probably realize that what people really remember from a gallery like that is not only the effect of the location of the picture, which I'm interested in, but also the effect of the saliency of the picture. So, different pictures should be remembered better, despite the fact, no matter where they were located. And you will be completely right. So to take this into consideration, we conducted a separate study on a group of 40 participants, 50 something, but after the data analysis, 40 were left. And they were asked to drag and drop the pictures in different batches, different sets, on top or on the bottom of the set which they have seen them in. And based on that, we constructed the salient, and they were asked to do it according to how much the picture draws their attention. And based on that, we've constructed this salience rating. So you can already see that some on the graph, you can already see that some pictures were actually perceived as more salient ones than others, and another was significant on that, of course. Another thing that we have done to take the effect of the pictures into account is to randomize the sequence of the pictures seen inside the gallery by each participant. So what the gallery was for participant 1, it's different for participant 2 or for participant 3. This was completely randomized. It was the same set of pictures, the same locations within the condition, but in different sequence. So what this allowed us to do is to disconnect the effect of the picture from the effect of the location. So we can take location number X103, for example, and calculate the average reaction time for the pictures seen on this location by each participant. We can take the miniature task, and we'll see that 69% of participants, 69% of pictures seen on this location were placed back on the correct wall in the miniature task. Then we can take another location, and we'll see that these things vary. So there must be something about the location of the picture which actually makes people remember them differently. And of course, we can calculate different spatial measures to try to find out what these differences, or where these differences come from. So the obvious thing is to calculate an isovist area and isovist shape. Another thing we have done after Stavrolaki and Poponis paper from Castelvecchio was to calculate what we call visibility catchment area, which is isovist restricted to 60 degree visibility cone. And the reason for that is that if you want a measure that will reflect the cognitive performance of a participant, you really need to realize that if someone stands here, even though this location is within the isovist of the picture, they can't really, they're probably not really processing this picture at the given moment. So we wanted something that, if you observe people in the art gallery, they usually tend to seek for the best place from which they can observe each artwork. So we really try to find something that will reflect that. So now, if we have our locations, we can add these spatial measures to them. So we can add isovist area, for example. This is in arbitrary depth map units, and one of the reasons for me to be at this symposium is to find out what these units are. So if anyone has any idea, I'll be really grateful. Other measure that we calculated was how many pictures were located in the isovist of each area, of each location. So for example, standing at the point of this picture, you can see two other pictures. Probably this one and this one. And standing at the location of this, you can see this, and this. So this reflects somewhat possible co-visibility of pictures, can be a part of this distraction factor, however you would like to call it. And on top of that, we can also look at the averages of spatial properties of locations across the conditions. So we can, based on that, we can try to find out what actually differs formally these two layouts. So one thing which differs them is that on average, each picture in this condition can see more other pictures. More other pictures are located with its isovist. If anyone is unfamiliar with box plots, this is median. 50% of results is this part of the box, and this is another 50% of the data points. Another thing is the average size of the visibility catchment area. So this 60 degrees visibility cone, and it's much smaller in condition number 2. And the reason for that is that if you look at it, most of the pictures in condition 1 are located towards the center of the wall, and if you locate a picture closer to the corner, you will lose much of this area. And just to show you what doesn't differ these conditions, isovist areas are on average almost identical, and so is the shape of the isovist. Area perimeter ratio in this case. Right, so for the results. Let's look at the computer recognition task first. So this is the object focus memory. And the participants were much faster in recognizing pictures. Participants who saw the pictures in condition 1 were much faster from those who saw it in condition 2. So we can already see that there is something about space in condition 2 that makes it sort of more difficult to recall the pictures seen inside. And if you want to find out what it is, it can be the size of the visibility catchment area, which is negatively correlated to the average reaction times on each location. So these data points are locations. Right, and for the miniature task, so the difference is that the miniature task was aimed to measure spatial memory, which is a bit different from simply remembering how something looked like. It's remembering where it was. And there is a distinction in psychology about that. So looking at the personal means, we couldn't really tell much because the spread of the results in condition 2 was so large. The reason for that probably is that some participants acquired a different strategy of responding to this task, and some got really well, some got it really well, and some got it really badly. So this is one thing we'll try to investigate further. But we can look at this data from different points of view, and we can see that that this potential co-visibility or other pictures located within isovist, the number of these is negatively correlated with the results of the miniature task in condition 1. So what this means is that the less pictures were possibly co-visible for each location, the better you were at recalling pictures seen at this location in the miniature task. And this was not the case at all in condition 2. This didn't have any effect. Even though, on average, there were more possibly co-visible pictures in this condition. So what guided their recall in condition 2? It looks like it was the salience of the picture. So remember I told you about this separate experiment we done to assess the salience of the picture on 40 participants. So this was highly correlated with the results of the memory test in condition 2. So what it looks like is that when the story that this data shows, I think, is that when the viewing conditions are comfortable, when the viewing conditions are comfortable, then it looks like it's the space which really guides what visitors will remember. But when it's when the viewing conditions get not so comfortable, when there is a lot of distractors and you can see many pictures at the same time, it looks like the salience of the picture takes really over and wins this fight for our cognitive resources. Visibility catchment area seems to be crucial in this, and the reason for that, we think, is that when you assume any random path throughout the environment, through this art gallery, the probability that you will fall into a comfortable position to view any given picture is higher if you have higher visibility catchment area on average. Even though the eyes-of-its sizes were the same, so visibility catchment area, suggested before in other papers, looks very promising here. What is bad, but what is good, right? So the problem with this is that, well, it's not really a problem, the limitation is this, that even though it looks like we have, so it looks like we can really tell what constitutes a bad art gallery, right? It looks like we've seen that when viewing conditions are uncomfortable, this really influences how people remember the pictures from inside. But, is there really a good and perfect art gallery? I don't really think so. It looks like there might be or might not be some threshold at which the viewing conditions become really uncomfortable and start to be a problem if you want to have an effective art gallery, let's call it. But also we need to remember that there are curators, artists, and art galleries which want to actually build an experience like that. So perhaps we can relate that to what Alan said yesterday, that science shouldn't necessarily measure everything. And I'm absolutely happy to put the boundary of this research right here. So what's next, we think? This requires another experiment, which will show us which will shed some more light on the relations between different spatial properties of the locations. And if you have any ideas, I would be very happy to hear about them. This is the perfect place for me to be, to find out what other spatial measures I should look at. I was thinking about the revelation points, so areas where eyes get bigger instantly. But this is for the future. And we also conducted another study at a working art gallery, which is the Baltic Center for Contemporary Arts in Newcastle. And it was a really interesting experience for an experimental psychologist to do a study in a running working art gallery. Very stressful, I would say. But we'll see if the results of our experiments can actually predict what people remember from a real art gallery. So this is next. Thank you.
Thank you. We can take a couple of questions.
Hi, thanks for a very fascinating research work. I have perhaps a more theoretical question. I think that this experiment is really fascinating, but I want to ask about how you define memory and how you define it in relation to psychology and to curatorial theory. Mm-hmm. So what is the significance of this, remembering the pictures and remembering the position in spaces and remembering the space as well to processes of learning?
Mm-hmm. Right. So as other studies showed, there is, if we're talking about spatial memory, if we're talking about remembering where a picture are, this can be related to how well people might be able to perceive different relations between art pieces located in the gallery. So Perhaps this is where something I haven't done here. But perhaps if they remember that pictures were located together, perhaps they see them as something that has some connection, not only spatial connection, but connection in terms of the curatorial intention. So maybe they are related in a way. When it comes to the other memory tasks, the computer recognition test, this purely measures like the trace of this object in your memory. And the reason for this is that basically what literature shows us is that the more people attend to something, not necessarily look at it, but the more effort they want to put into processing it, the better they will remember it. This is why I call it spontaneous memory. It's not something you don't go to an art gallery to memorize pictures. But if something drew your attention, if something interested you, you will remember it better. And this is what it aims to show. Does that answer your question?
Partly, but perhaps we can continue.
Sure. Yeah.
So one more question. John?
Thank you for your presentation. I really enjoyed it. It's a comment more than a question. I think it's wonderful for space syntax that we move from simply asking how space drives paths into then asking how space drives attention. And you showing, and maybe some of our recent work also shows how then space impacts cognition directly. In your case, you have a unchanging layout because you're using real space. In our case, we used virtual reality so we could change the layout. The weird news from our research was that we could not find an impact of the different layout types on the effects of visibility in recognition. So, from an architectural point of view, it would be nice if you could figure out if there is any experiment that will get closer to linking findings that pertain to the spatial dimensions of cognition to design choices. Right now, you're helping enormously go from space to cognition, but you're not yet, nor have we been able to go from that to design choice. So I'm just pointing that out as an interesting challenge that it would be wonderful if you could take a step in that direction also.
Right. Okay, so what I hope this could contribute is that if you are a curator and you're designing a new art gallery or a new exhibition, you could test different possibilities. You could try them out and see how visibility catchment areas relate to each other in different design possibilities, right? But of course, yeah, this is a challenge.
Okay, I think we're going to have to move on, and thanks, Jakub, again.